Hello. So I'm going to be talking about GraphQL Boilerplates. But before that, thanks to our sponsors. Hola, Alicante. Hola? OK. So yeah, I'm MANJULA, and I'm a senior consultant. I basically work on React. I'm also a lecturer at Code University, Berlin. I'm based out of India. I'm originally from India, but I kind of stay in Berlin right now. I'm working there. So yeah, do you think a lot? Yeah? No? OK. I think we think a lot when it comes to our stack. When it comes to our stack and when it comes to starting a new project or new boilerplate, yeah, we think a lot, yeah. And yeah, the question is like, which framework should I use? How do I even start, right? I mean, there are a lot of questions that comes to our mind, but I would say I have a solution for you. Take a deep breath. Let's take a deep breath, everyone. Yeah? OK. So this is a space that we are kind of working on that's called Awesome GraphQL Space. We are two people who are kind of working on it, and we started it just 1 month back. The reason I started it is because I saw there is a lot of gap between when we start, adapting to new technologies. As a beginner, we really don't know how to start, and that's where I started with. So this talk is going to be walked through to the GraphQL, how to get your GraphQL server running up, as well as your GraphQL client. That means using it with React or Vue. So our server is basically a combination of your Nest.js, Prisma. I'm going to tell you what is it all about. So yeah, Nest.js, Prisma, and Apollo, and how are we going to integrate it is the main thing that we're going to discuss here. That's the space. You can just go and visit all of these. It's their server, React, and Vue. Now, the question is, so we chose, as a server, we chose Nest.js framework. But the first question that comes to my mind is, why not plain Express server? I mean, why do I even have to choose a framework for it? So the reason is, when we start, sometimes it is difficult to extend. Like when you are playing around with Express Server, or maybe as a junior developer, or maybe you're just starting, it becomes difficult to extend. And you might land up where it's a total mess. It's really a mess, and it's hard to scale. That means if you're trying to scale horizontally and vertically in terms of your application, it becomes hard to scale. So it might end up something like this. So as a junior developer, if you are trying to maybe, say, set up your Express server, you might just download all of the NPM packages in your package.json, right? And so here's a solution, Nest.js framework. It's a kind of progressive framework that gives you an efficient and reliable way to set up your Node.js server very quickly. And it also follows a dependency injection pattern. So it comes up with that pattern. And this is one of the frameworks that chooses a lot of best practices from across the community. So you have like all of the best things out of the community. And it also supports, it is also compatible with a lot of other libraries like Fastify. So yeah, it was a best choice for us to go ahead with this. Next, it is like I said, it's a very quick setup. It is already beta tested. You really don't have to dig your head like what to use, what not to use. It's already beta tested, and you already have things in place. It reduces your time of setting up your boilerplate using what you would do using your Express server. But let me tell you that Nest.js under the hood still uses Express Server, because Express Server is kind of one of the best patterns. So it is something like this. You know what you want, and it is kind of easier. If you start as a junior dev as well, it is much easier. So he is a creator of Nest.js. He's a super cool guy. So, yeah. So for us, the motivation was, there were a few motivations that we wanted to go ahead with Nest.js in the boilerplates. Open source. We all love free stuff, right? Yeah? Don't we? Yeah? So yeah, it was open source. Secondly, it gave us the power where we could set up things very quickly. We did not want to waste enough of time. Third, oh wow, I love this slide. So it had support to both JavaScript as well as TypeScript. So this was one of the things, like, we chose Nest.js. And it had GraphQL module in it. That means you really did not have to worry about your GraphQL things being in place inside your server thing, but it already had GraphQL module. Now, the GraphQL module in Nest.js is nothing, but it's like a wrapper around your Apollo server. That means whatever you need to pass, you can still pass, because under the hood, you still have Apollo server running. So this was a win for us. Like, it already had the Apollo server to support. So this got released, if I'm not mistaken, last week, because it still did not support Apollo server 2. So this was a release which was made last week, which is in 5.1 version. So yes, I mean, the previous version doesn't support Apollo 2 server support yet, the inbuilt Apollo 2 server, but GraphQL 5.1 supports. So there's some important announcements that I would like to tell you. In fact, it's a kind of good news for those who are in terms like decorator patterns. So Nest.js now supports pipes. You can use pipes. You can use arcs, decorator patterns, so all the decorator pattern lovers can use Nest.js. The way you start is you basically say globally install the CLI, and you say, I want to build my project. So it kind of will generate you a boilerplate for you. And you also have to install the GraphQL module, the Nest.js GraphQL module. You say Apollo Server Express. You also need GraphQL tools because you want to play around with the schema, and you need GraphQL. Now the things are very simple. You register your GraphQL module from Nest.js GraphQL module, and then what you do is you pass in your type defs, you pass in your resolvers, you pass in your context, because under the hood it's still using the Apollo server too, so you can pass in all of the stuff, like you can pass Playground, true or false. If you want to use Playground, you can say debug true or false. So you still can use all of the options that you would pass to the Apollo. And so it's damn simple. Now, to bootstrap your app, what you do is you just say Nest Factory, create my module, and I want to be listening to this particular port, and that's it. You're done. But we had something called Prisma, because if we don't have a database, it doesn't make sense. So Prisma kind of took care of sitting between. So if you have your database and if you have your GraphQL server, Prisma takes care of sitting in between and taking care of all of the complex queries that you would make to the database. Like, it's basically a communicator that sits between the GraphQL server and your database. And it comes up with a lot of features, like it gives you code completion. You really don't have to worry about your database language for making a query. Instead, Prisma would do that. Like any of the complex queries, it would just take care of that. So it's basically turning your database into GraphQL API. That means it is kind of making easier to work with GraphQL. So how do you set up your Prisma? Is very easy. You say npm install Prisma. You basically install the Prisma CLI. And the next thing is you need to log in to Prisma. You have to register on app.prisma.io before that. Now, once you say Prisma init, so basically this boilerplate uses Prisma. But since everyone would have their separate login, you would need to do this is because when you say Prisma init, it will kind of generate, it will prompt you 4 of the options for you, whether you need to use your own database, or you need to use the existing database, or you need to use the demo server. In my case, I'm going ahead with demo server. The demo server has the Prisma Cloud as the database, so I really don't have to worry about the database thing. And I go ahead with demo server, and it gives you an option of selecting your demo server region. You can choose either of them. And then it generates these 2 files, .prisma.yml and datamodel.graphql. That is your schema file. Now what you do is you basically take this endpoint that got generated in this file, and you replace it in your .env file, that the GraphQL server folder. You basically replace here. And the next step would be deploying. I mean, I have my endpoint. Now I need to basically deploy my database. That means my server. So it's just Prisma deploy, and it gets deployed. So remember, if you're on local machine, you would need the Docker setup, because if there's no Docker setup, you can't basically deploy. So you would need the Docker setup, and then you would say Prisma deploy. So Prisma Client, yeah. So they're coming up with, they already came up with this concept of Prisma Client, where it's nothing but it's like an auto-generated library that would generate all your typing files and resolvers for you. It basically simplifies the use of Prisma. As a user, I would need things done in like command line stuff. So it basically simplifies all of your stuff. The way it works is, so yeah, they released it 2 weeks back also. This is a beta version that they are rolling out. So it's type safe as well. The architecture here shows you that you still have Prisma server, but Prisma Client kind of takes care a lot of things for you, like generating resolvers, generating your GraphQL API. So a lot of stuff is taken care from Prisma side, Prisma Client. So this is a kind of architecture. Now the best part about is whatever the Prisma Client generates is kind of type safe. So you really don't have to worry about type safe. It generates type safe resolvers and schemas. So this is still in beta. You can go and check it out. The beta version is what we are using in the GraphQL boilerplate on the server. So this is the architecture, and now now the step is, how do we generate your client? That means your type files and schemas. So as said, it is 1.17 beta. It still uses the Prisma CLI. So you say npm run Prisma generate, and it generates the 2 files for you, the type files. But it reads the prisma.yml file. So you say, based on your schema file, that is your data model.graphql, generate me in TypeScript language the type files, and you can also generate your schema files. So all of the things are taken care. Like, you really don't have to write things. Since Prisma is a kind of communicator between the database and the GraphQL server, it does things for you. Also, it doesn't only support TypeScript. It also supports, like, as a generator property specified here, it also works with Golang. It also works with JavaScript. So it is available in a lot of other languages as well. So once you do Prisma generate, it reads this file. That means prisma.yml, and it sees, OK, fine, I have to go and generate prisma.ts file, and I have to generate my schema file as well. And that's how it generates 2 files. So you're really not doing anything. There's also one other way. You could also do it by placing all of the stuff that you're doing it here in your .graphql config file. But this is the most preferred way of doing stuff. So I would not suggest doing this. Now, the next step is, like, you want your data model.graphql file. That means you have to define your data model. So in my case, what I am kind of building in the boilerplate is, sign up, log in, and as soon as I log in, I basically need to post my tweets. So that's what I'm doing. So that's where I have the user model and I have the tweet model. I also need my schema because I have my data model, but I also need my schema file because this is where schema will be used to decide, what mutations you want, what query you want, whether you're playing around with authentication or not. So this is how you basically define your schemas. And yeah, this is the worst part. This is not the worst part. This was the worst part before because you still had to write your resolvers. But now Prisma Client gives you a way where you don't have to write your resolvers. So there's a tooling around Prisma Client, which is GraphQL Resolver Code Gen, which kind of makes it simple for you to generate all of your resolvers, which means the resolvers are type safe. So what you do is you basically say resolvers interfaces. So what happens is before generating your resolvers, it has to generate your interface because based on the interface, it will kind of generate your resolvers. So what you do in your package.json file, maybe you could say GraphQL Resolver Code Gen, generate me interfaces, and this will be generated based on your schema file. That means based on your schema.graphql. So whatever data model you provide, it will kind of build the interface, which will then be used to generate your resolvers. So then next thing is you scaffold your resolvers, and you say, hey, go and generate me all of the resolvers. So it will have all of the resolvers. So you see all of the resolvers is already generated. You really did not do the manual stuff of writing your resolvers. So you kind of reduced your time there. And now, if I'm telling that you have your resolvers with you, that doesn't mean that your resolvers are implemented. It just gives you a skeleton where you still have to go and implement your resolvers. So implementing your resolvers would be the next thing. So in my case, this is a small example of sign up. What I'm trying to do here is basically check whether the user exists in the database or not. So since for me the database is Prisma Cloud, this is what I'm trying to implement here. This could be with whatever mutations or whatever mutations that you are trying to do in your boilerplates. So this is one of the examples where I am implementing the query. That means I'm implementing the queries because I still have to fetch my tweets. So this is how you basically implement your tweets. Now, if you see ctx.db, basically we already passed the context in the GraphQL module, as I showed you on the first slide. So you actually get access to ctx.db, and you actually can get hold of all the fields that you basically want. This is one of the cool thing, which is they also support auto-completion and linting, which means you still have to go in your context.ts file, which still holds all of the context to your database, and you actually have to say db is Prisma. Because when it kind of generates your resolvers, the DB would be here nothing. You still have to go and write Prisma because it still wants the context to the Prisma database. So now, with Prisma being in between as a glue between your database and GraphQL server, you kind of have the capability of doing all the CRUD operations that you want to do. Now, Apollo 2, it is not really a big thing because since Nest.js already supports Apollo 2 server, it was not a very big thing. But when it was kind of not supporting, then we really had to do a lot of stuff. But now it's easier. Since Nest.js already supports Apollo 2, it's very easier. We already did this step at the first go, so Yeah, so that means GraphQL module is kind of taking care of everything. You really don't have to worry about anything. You just pass your resolvers. So type defs here are nothing but the schema files that you are passing to your GraphQL module. And as mentioned, you are passing your DB to the context. If you see you're saying return DB, that DB is nothing but you actually instantiate your Prisma. And you pass in your endpoint to it. So you're still referring to the Prisma database because I'm using Prisma Cloud as my database. In order to play around with subscriptions, you also don't have to worry about things. You just have a flag wherein you say, hey, install subscriptions, handlers, true or false. And it is taken care of. Exposing the GraphQL endpoint is, the default is like localhost 3000 GraphQL. You could change this, depends on you. You could change the port number, but the default is localhost 3000. Since it supports Apollo server, Apollo 2 server, Apollo 2 under the hood uses GraphQL Playground, which is built by Prisma. So you also have access to GraphQL Playground. So the integral part here was mainly to understand how you are using Nest.js for building up your server much easier or in a faster way, and using Prisma to solve the problem of database. So what are we supporting currently in the boilerplate is we are playing around with authentication, so we're supporting authentication JWT. We are using Prisma GraphQL. Apollo Server 2 is inbuilt supported, so we really did not have to bother about it. But what we are going to support in like next few weeks is authentication passport. So we're going to use passport.js. We are going to use session-based authentication. We are also going to try and do some real-time subscriptions. There were a lot of reviews that we got that people are much interested in file upload via GraphQL, so we are going to pick up that also, and yeah, obviously Redis support. So before we move on to client, let me just show you the server. So this I have already hosted it on now, so it's fine. And since it is based on authentication, I already have my JWT token here, so it's my user, so you really don't have to. And now I just go and say, hey, query, get me tweets, and ID, and get me the text. So you have it, and maybe I also want the author, maybe the username, and maybe the display name, because that's what I have built. And you see all of them, right? And you also see that your playground also has all of the schemas here. So if you see tweets, current user, sign up, login, and the subscription. So this is a playground where you can see all of the schemas that you've defined here, and basically you can query here to get your results. This is built by Prisma. So we go back to the client slides again. So next thing was client. We wanted to be sure that we have the server running, but we wanted a client boilerplate as well, which kind of uses React, Apollo, and GraphQL, because it is difficult when you start as a beginner to understand what is running where and how is it actually happening. So this is the space. It's called Awesome GraphQL Space React GraphQL. You can go and check. So for the folder structure, I'm mainly concerned with keeping it the way I have kept it now. You basically can keep all of your GraphQL stuff inside the GraphQL folder. You can have components folder. You can have screens based on the pages that you're navigating to. So yeah, in this GraphQL Client boilerplate, we are also using Apollo link state. That means to manage your local data, we are kind of using Apollo link state. So Apollo link state is nothing but it's like a Redux for your GraphQL. And yeah, so you can manage your local state with Apollo link state. So there are examples in the boilerplate. We are also supporting query components. So in React Apollo 2.1, you have query components. So we are also supporting query components in the GraphQL boilerplates. So we are supporting Apollo mutation and query components. That means I'm going to explain you in a bit what are Apollo mutations and query components. These are nothing but it's like previously we used to do things much in like HOC pattern, which is like high order components, but now it's more like render props. So this is the way how you basically get your GraphQL results on HTTP network. So basically you just have to do this step and you say import HTTP link from Apollo links HTTP. And basically, since you're dealing with Apollo local state, you kind of have to basically import Apollo link state, and this is how you actually set up your local state. So you have to basically pass all of your default states, your resolvers, and type diffs. So if you're dealing with cache, you basically have to initialize your Apollo cache this way, and it's like you import Apollo cache in memory. And this is how you basically set up your Apollo client. So you say import Apollo client from Apollo client, and you pass link, cache. If you want to pass connect to DevTools, true or false, that depends on you. And yeah, here's your like Apollo client setup. The next step is to basically connect your client and the server. So for that purpose, you use React Apollo. The way you do it, you basically wrap your app with the Apollo provider, and you pass in the client. So I was talking about mutation components, the way we basically pass using render props. So this is your query, and what I do in React, I kind of say, hey, mutation query components, just basically pass in the login query to it, and you can have various state based on it. Like here, since it's a login mutation, I have mutate, login, and error as a parameter. And you could do whatever you want to do here inside. So yeah, so this is how the mutation components work. And this is a small example of query components. The way it works is the same way as mutation components. You basically pass in your query to your query components, and it can have like different phases, either loading, error, or data, based on in whatever phase it goes. So for all the Vue lovers, we also have a Vue client. Like we made sure that you're not sad about it. So we also have the same feature for Vue. You can go and check out. So this is basically the URL for Vue. For client, we are kind of, the future roadmap is to support subscriptions because we've not implemented yet in the client. So stay tuned on this GraphQL awesome space because we have something new also coming up. We have ChatQL, which we are working on. ChatQL would be an add-on that will help you to add the chat support in your existing or new applications that you're building. So this will be in your existing GraphQL API. So we are still working on it. I hope it will be released by next month. So we are looking for contributors, like people who have ideas can come and can join us because we love ideas. So you can go and check out the awesome GraphQL space. Thank you so much, Alicante. And for females out here, I have some stickers. So please grab me and find the stickers. That's my Twitter handler, and thank you again. Any questions? No questions?
Thank you.
OK.